Okay, so it has some special characteristics. First characteristics for the unit circle is its center is at 0, 0, so that's the origin. Second characteristic of the unit circle, it has a radius of 1. Okay. I'm going to say 1 unit. That's why it's called the unit circle, because its radius is 1 unit. And the equation of a circle, you may recall from geometry, is like quantity x minus h squared plus quantity y minus k squared equals r squared, where h and k is your center. So that's just going to break down to be x squared plus y squared. And then it equals r squared, which we already know the radius is 1. So 1 squared is 1. So it fits this equation. If you want, you could draw a quick sketch of what a unit circle might look like. It's really not too terribly exciting. Like that. There's your unit circle. Now, what is below here behind the shade, you don't really have to write down in your notes because you should have it in your notes from yesterday. It's just a review of geometry and special right triangles, because we're going to be labeling some things on the unit circle, the circle centered at 0, 0 with radius of 1, and we're going to be using the special right triangles. Now notice I have 3 triangles up here, but there are really only 2 special right triangles. That's because we're going to see 2 versions on the unit circle of the 30, 60, 90 triangle. One version is going to have 30 at the origin and the 90-degree angle on the horizontal x-axis. Okay, the other version will be 60 at the origin and 90 on the horizontal x-axis. Okay, so these right triangles are going to show up in all 4 quadrants, and you don't have to draw anything on this next slide either, just kind of look and see. They're going to show up in each of the 4 quadrants, and they have to be orientated always so that the right angle of your special right triangle is on the horizontal axis. So everything is in relation to this x-axis. So if I draw in for this first example, I got right angles always on the horizontal axis. Now this is probably hard for you to see at the back, but this says pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So this is the pi over 6 family, which pi over 6 is 30 degrees, right? So this is an example where 30 degrees is at the origin and the right angle is at the x-axis. Okay. Now, I call these shapes butterflies. You may see them as a bow tie. Okay. One thing to be important of when you're doing trigonometry, never should you ever draw a hourglass. Hourglass not allowed here. Okay, so make sure that you always got butterflies and bow ties. Those are the angles that you want. You should have seen something similar to this in Algebra 2. It would be when you talked about reference angles. Okay, so we're going to come back and talk about reference angles next week. But basically, we're using reference angles in the special right triangles to create the unit circle. Okay, so these are the 3 different versions of the 45, 45, 90, and 30, 60, 90 triangles around the unit circle. But there's one issue with those special right triangles that we know from geometry that I had you label yesterday. When you look at these pictures and you imagine like 4 triangles in each of those pictures, what part of the triangle is the radius? The hypotenuse of each special right triangle is representing our radius, right? So as we look in any quadrant, the thing that represents the radius of the circle is actually the hypotenuse of the right triangle. And we're going to have an issue because if it's on the unit circle, the radius is supposed to be 1. And right now, with the 3 special right triangles that you know from geometry that I had you write down yesterday, those don't have hypotenuse of 1. So we got to think about a way that we can get a similar triangle, same shape, 45, 45, 90, 30, 60, 90, but a different size triangle so that its hypotenuse is equal to 1. Essentially what we want to do is, right now we've got a hypotenuse of square root 2, and then also a hypotenuse of 2, which both of those are greater than 1. We want to take those triangles and we want to scale them down. So anybody got an idea how we could scale down our hypotenuse? It's square root of 2. Chloe? Divide by square root 2. It's essentially multiplying by the reciprocal 1 over square root 2, which would be kind of like, you think back to geometry and similar triangles, a scale factor. So we're going to divide it by square root 2. If I do that to the hypotenuse, in order to keep the same shape, to have the similar triangle, then I've got to do that to the legs as well. So these are going to get divided by square root 2. You don't necessarily have to write all this down yet. I'll tell you when to write. Okay. Now what are we going to do with 1 over square root 2? Fix it, rationalize its denominator, right? We're going to get square root 2 over 2, which that should sound familiar to you from trig, square root 2 over 2. You encountered that quite a bit last year. Okay, so this is where those numbers are coming from is a good reminder. When we're looking at the 30, 60, 90, now we're going to divide by 2. And so those are going to be the other values that we're going to encounter when we do special right triangles around the unit circle. And again, I have 3 pictures, but I really only have one version right over there, right? So we're working with a triangle with a hypotenuse of 1 and side length square root 2 over 2. And a triangle with hypotenuse of 1, side lengths 1/2 for the short side, and square root 3 over 2 for the long side. Okay, so 1/2 is the smallest there. Okay, so what I'm going to do next is I'm going to come around and give you a small pink triangle and a small blue triangle. The blue triangle is your 45, 45, 90. The pink triangle is your 30, 60, 90. And we're going to use these to help us build our unit circle. Label all angles. Label all sides. And label the front and the back of the triangle, because you're going to be like flipping it around and moving it, so you need all of it. Okay. So I'm going to move to the next slide. Well, actually, I have, hang on one second. I'll put it on the next slide for you so you can see what I'm talking about. So this is my blue triangle right there. Okay, so I labeled my right angle, I did 45, 45. My hypotenuse should be labeled 1, and my side should be square root 2 over 2. And then also label your pink triangle, but label the front and the back. So these are the scaled down versions of the special right triangles that will fit into the unit circle. Hypotenuse of 1 will help us form those butterfly shapes that we saw on that previous slide. Remember that when you're labeling the pink triangle, the short side has to be 1/2. The longer leg will be square root 3 over 2. Okay, so next up, after you get your triangles filled in, you've got the unit circle in front of you now, and you want to start filling in some of the basics of the unit circle. So in the next few chapters, we're going to be talking a lot about quadrants. If you need to label the quadrants, go ahead and do that. That's kind of up to you. Quadrant 1, 2, 3, 4 moves counterclockwise. The other thing, really quickly, is you already know some of the coordinates around the unit circle just based off the fact that we have center at 0, 0 and a radius of 1. So we know if we go 1 to the right, we have a point at 1, 0. If we go 1 up, we're at 0, 1, negative 1, 0, and then slide this up, 0, negative 1. The other thing that I have labeled on my unit circle, but is not yet labeled on your unit circle, are all of the angles on the inside. So notice that inside your circle you have two blanks. One that's labeled degrees and one that's just a blank where you're going to put your radian measure. It may be hard to copy from the board, so remember you have all those angles from Tuesday. I gave you that little yellow square paper with all the angles. So if you want to find that in your notes from Tuesday and just copy your yellow square, go ahead and do that. That would be a fast way to do it. If you're not sure what you should be filling in, ask a neighbor or ask me. We'll be happy to tell you. Now, we want to focus on the patterns of the unit circle today. I will teach you eventually a hand trick that you can use if you struggle with memorizing the unit circle. But when we're working with our blue and our pink triangle in the unit circle, try to pay attention to some patterns that you might notice so that you could use this to help you recreate the circle. You're responsible for the unit circle on a quiz and a test. It will not be provided for you. So next up, you're going to take a highlighter, and it doesn't really matter what color you choose for your highlighter, because you'll be using 3 different colors here. Okay, take a highlighter, and we're going to highlight the butterflies. Okay, so we're going to do one at a time, and this will help us to see some of the patterns. So I'm going to take a piece here. I'm going to start with the smallest angle in quadrant 1, which is 30 degrees or pi over 6. We're going to draw the right triangle that's part of the butterfly. So you're going to start at the origin, follow it out to the point on the unit circle. And then remember, you always draw your right angle back to the x-axis. So it's got to be going down to the x-axis. Okay, there's my right triangle. Now, there's a triangle similar to that triangle in all other quadrants. I'm going to do quadrant 2 next. Would 120, 135, or 150 look most like the one that I have in quadrant 1 right now?
150.
150, right? Okay, so we're going to go from the origin out to 150. And remember, always go back to the horizontal axis, the x-axis. Okay, so we'll come down here. And you're making a right angle. You're not following the curve of the circle. You're coming down and hitting at a right angle. And then pretty easy, just reflect those over. Okay, so I'm going to go down, over. Okay, so I've drawn a bow shape. Now, these 4 angles, I like to say, are part of like the same family or group. By degrees, we have 30, 150, 210, and 330. If you look at the radians for those 4 angles, what do you notice about those 4 angles in radians? They're all of the pi over 6 angles, right? So pi over 6 angles are always part of the same family, and we're going to uncover what their coordinates are, and we're going to see some pattern there. So now take your pink triangle, and you're going to try to fit it in to that highlighted section. I'm going to start in quadrant 1. Try to fit your pink triangle in quadrant 1. Remember that your right angle has to be on the x-axis, and it's got to fit in that butterfly shape. So I have one ready to go. Just pull it right over here. Ish, right there.
This one's the best one.
Okay, so now what we're going to do with our triangles is we'll be able to fill in all the coordinates around the circle. The coordinates represent, just like on a coordinate plane, how many I move right, left, up, down. For this particular triangle, how many did I go to the right?
Radical.
I went radical 3 over 2. Look at the side of your pink triangle, right? How many did I go up? 1/2. So then I can label my coordinates. This is radical 3 over 2 and 1/2. Now move that triangle. Easy way to move it is just to kind of like think about flipping, like doing reflections. Okay, so if you reflect it over the y-axis, I don't think I have that luxury. I don't know if I'm going to be able to get it to fit in there on the smart board. Oops. Undo. But you guys can turn it, right? I'll leave this one here. I've got a hard copy one I can hold up to this one for. Okay, so here was my pink triangle, and now I'm going to reflect it. Okay. What would be the coordinates in quadrant 2 for 5 pi over 6? Negative square root 3 over 2, positive 1/2. Do another reflection. Reflect it over the horizontal axis. Now we're at negative square root 3 over 2, negative 1/2. At this point, some of you might be able to say, well, I know it's going in quadrant 4, right? I'm going to the right, so it's positive square root 3 over 2.
Mm-hmm.
And I'm going down, so it's negative 1/2. So not only does this family all have the denominator of 6 in radians, but you're going to notice a pattern between those families on the butterflies or bow tie shapes where their coordinates are essentially the same, square root 3 over 2, 1/2. It's just they change signs depending on which quadrant you're in. Did you go left, right, up, down? Okay, so now you can use a different color highlighter if you would like to. Highlight the next family, okay, which is going to be 45 degrees, or the pi over 4s.
I'm not sure I got that.
Remember, always draw it back to the horizontal axis. If you go back to the y-axis, you'll create an hourglass, which is no good. And then because you're working with pi over 4, which is 45 degrees, you're going to need to pull out your blue triangle. I'm going to let you do both of the other families. Fill in all the coordinates around the unit circle. Let me know if you have questions. Ask your pod if you have questions. We will help you.
Oh, this bow tie's not as good.
Yeah, sometimes people have trouble with bow ties. Don't worry. Bow tie doesn't really matter, right? It's just aesthetics. So find a way to fit that blue triangle in your second butterfly and label your X and your Y all the way around.
Nope, the radical 2 over 2.
As you're doing it, think about patterns.
All students do.
You got it.
Green, green. I'm just trying to get the best colors. Yellow's not the best color. I think yellow would have been good for me on the instead of the orange.
Yeah.
Not yet, but I just wanted to see how good my colors were.
Once you get the pi over 4s, move on to pi over 3s. Fill in all the coordinates. If you want to use another color, you can do your last butterfly.
I don't like this. I don't like this. I'm getting a headache. I'm looking at it. Three-dimensional. Triangles. I see the triangles on the look at these like walls. See what I'm saying? This is the floor. This is the ceiling. These are the walls. And that's it.
Now, mine on the board gets messy real fast. And when you look at it, it's sort of alarming, at least for me. I will, by the end of the day, post my answer key to my unit circle. So if you feel at any moment that you need to go back and check and see that you have the right numbers and the right signs and all that stuff, you can go ahead and do that online at any point. I'll also post a blank unit circle, so if you ever want to print a unit circle to practice with, you can also Google unit circle and you'll find lots of resources as well. Now notice when you do that last family in the butterfly, you go back to your pink triangle because it's the 60-degree angle. So you're going to see the same numbers in your coordinates, but they're going to be flip-flop for x and y. So now they're all 1/2 square root 3/2's, and they change signs around the unit circle. One way that you can check to see that your unit circle is correct once you figure out what the coordinates are for each of the angles is look at all of the coordinates in quadrant 2. So look at all the pairs for 120, 135, and 150 degrees. What do you notice is similar for all of those coordinates? The x is negative, the y is positive. So that's also a great way for you just to check if you have the right signs. Quadrant 1 is going to be positive, positive. Quadrant 2 is going to be negative, positive, xy. Quadrant 3 is going to be negative, negative. And quadrant 4 is going to be positive, negative. Okay, so I'm going to move on, and we're going back to our notebook now, and we're talking about, okay, so now we've labeled all these coordinates on the unit circle. Well, why the heck would I ever do that? How is that going to be good for me? Okay, and here it is. We're going to be talking about trig ratios on the unit circle. Now, we talked about trig ratios yesterday. Sine, cosine, tangent of theta, some angle. If we know what theta is, we can use our calculator, make sure we're in the correct mode, degrees or radians. If we don't know theta, but we know the sides of the triangle, we can use SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse, opposite of adjacent, and flip as necessary for reciprocals. I'm making one tweak today and saying we're not going to be doing sine, cosine, tangent of any angle. We're going to be doing sine, cosine, and tangent of angles that appear on the unit circle. I could put a little addendum there, or are coterminal to angles on the unit circle. And I'm going to call those angles T. So that T just represents, it's a special angle from the unit circle. And this rule that I'm going to put up here for sine, cosine, and tangent, it only applies if that angle comes from the unit circle. So if I were to give you 57, we can't do it. It's not on the unit circle. Okay, so I'm going to draw the image of a circle, a unit circle specifically, I suppose. Here's my unit circle. I have some angle T. So remember it has standard position, initial side is on the positive x-axis, and this is a positive angle opening, counterclockwise, angle T. If I wanted to do sine, cosine, and tangent for T, I would need a right triangle, so I'm going to bring down my side perpendicular to the horizontal axis, and on this triangle, because this is the unit circle, I know the hypotenuse is 1, because the radius has to be 1. I don't necessarily know which T this is, if this is 30, 45, or 60, so I'm just going to, for sake of definition, say that there is some x and y value as long as it belongs to one of the special angles on the unit circle. So if I asked you, looking at that image, what is the sine of T, you would tell me sine of T is y over 1, which is just y.
I was thinking tangent.
The sine of T is y on the unit circle. The cosine of T is x. And Tom, the tangent of T?
Y over x.
Y over x. Now, this should sound like vaguely familiar because you did do, and we're going to do it next week, trig functions of any angle, where you did y over r, x over r, y over x. Okay. But here, r is always 1, so our sine and cosine are going to simplify just to y and x. You could do the reciprocals real easy, 1 over y, 1 over x, and x over y. So it's like, what's the big deal about the unit circle? The big deal is if you know the unit circle and you're working with special right or special angles from the special right triangles, which we will a lot in pre-calculus, calculus, and beyond, then sine is y and cosine is x. Awesome. Now I'm going to go back to my unit circle, and I'm going to write that on my unit circle. I'm going to say xy is equal to cosine t sine t.
You remember that? I don't remember.
The other thing I'm going to do real quickly is do all my tangents in quadrant 1. Because tangent, unfortunately, is y over x. If we simplify it once in quadrant 1, then we know it's the same for that whole like family part of the butterfly. It's just going to change signs depending on which quadrant you're in. Okay. So let's just do tangents here in quadrant 1. If we were doing tangent of 0, we'd be doing y over x, which would be 0 over 1 or 0. If we were to do the tangent of pi over 6, I'm going to do my work off to the side on this sideboard. I'd be doing y, which is 1/2, over x, square root 3 over 2. So 1/2 divided by square root 3 over 2. Well, to divide fractions, I really multiply by the reciprocal, 2 over square root 3. 2's will cancel. That's 1 over the square root of 3, which I then rationalize. And the tangent of pi over 6 is square root 3 over 3. That should sound familiar from Algebra 2. What's the tangent of pi over 4? 1. Y and x are the same thing, right? So square root 2 over 2 all over square root 2 over 2 is just 1. It's a nice one. Does anybody recall the tangent of pi over 3? Not square root 2 over 3. It's just radical 3. Yeah, it would be the reciprocal to this pi over 6, because then you're going to be essentially flipping your x and your y, right? Now y is the square root of 3 over 2. X is 1/2. That's the square root of 3 over 2 times 2. So that's just the square root of 3. And then the last one, the tangent of pi over 2, is 1 divided by 0, which is undefined. So you can use those in the other quadrants. Like if I were to ask you, what is the tangent of 5 pi over 6? The tangent of 5 pi over 6 will be in the same family as pi over 6, so b square root 3 over 3, but in the second quadrant, tangent will be negative. So it would be negative square root 3 over 3. I know it's going to be negative because my y and my x have different signs in quadrant 2. Tom said earlier, all students take calculus. That tells you which trig functions are positive in which quadrants. That's the only thing I'm not going to fill out on this sheet are those positive and negative things. They're on my key that I'll post online. But essentially that's just saying everything is positive in quadrant 1. In quadrant 2, it's only sine and cosecant. In quadrant 3, it's only tangent and cotangent. And in quadrant 4, it's only cosine and secant. So you could fill those in if you felt like it. Does anybody have any questions for me about what they're seeing on the unit circle? Did I write something wrong, Allie? It's very possible that I would. Just checking. Okay, here's what your homework is going to look like. When you're doing your homework tonight, it should be no calculator, unit circle should be out, and you shouldn't really be doing that much math per se because it's all done for you on the unit circle. Okay. They're going to give you a T, which is just a special angle from the unit circle, and they're going to ask you for the 6 trig ratios. As a beginner to the unit circle, what I would probably do if I know that T is equal to 5 pi over 5 pi over 4, can you find 5 pi over 4 on the unit circle?
My goal is to do stuff.
What?
So my goal is to do without the unit circle. So
Oh, you're going to try it without the unit circle. Cool. Do you know where, can you point to 5 pi over 4 in the unit circle? What quadrant is it in? Quadrant 3. Okay. So what I would do, and I'll give Tom a minute here. If I'm a beginner to the unit circle, I would write down immediately what the coordinates of 5 pi over 4 are. Coordinates, negative radical 2 over 2, and negative radical 2 over 2. It's in quadrant 3, so they both got to be negative, right? Okay, well that's cosine, and that's sine, right? I don't have to do any math. I'll just say the sine of 5 pi over 4 is equal to negative square root 2 over 2. And the cosine of 5 pi over 4 is equal to negative square root 2 over 2. And the tangent of 5 pi over 4 matches the tangent of pi over 4 that we put in quadrant 1, which is 1. It's either positive or negative. Because 5 pi over 4 is in quadrant 3, it should be positive. Because even think about this. If you did negative divided by a negative, y over x, you're going to get positive, right? And then I just have to flip it. This maybe is where your math part actually comes in, where you're actually calculating something. You probably only have to do this a couple of times. Once you do it a couple of times, then you know what the reciprocal is every single time. You don't have to keep redoing this. Okay. So if I flip negative square root 2 over 2 and make it negative 2 over square root 2, I'll have to rationalize my denominator, which will be negative 2 square root 2 over 2. So that's just negative square root 2. And that would also be the same thing for secant. It'll just be negative square root 2. So here's really nice. You now know cosecant and secant for every pi over 4 angle on the unit circle, right? It's always going to be square root 2 or negative square root 2, depending on which quadrant it's in. And then the reciprocal for tangent, the reciprocal to 1 is just 1. So cotangent is also 1. Okay. Questions about what I did right there? Now, if you get to a problem where your angle is not really on the unit circle, like t equals negative 4 pi over 3, just use a coterminal angle.
Pi over 3.
Not really, just add
Actually, no, it's 2 pi.
a full revolution, right? So I'm going to show my work. Negative 4 pi over 3 plus 2 pi, which is 6 pi over 3, will get me to 2 pi over 3. So use the coordinates for 2 pi over 3 to do negative 4 pi over 3. Okay. Yes, Chloe. No, so like in this particular section, I should only be asking you angles that will show up on the unit circle. If I ask you about angles that don't show up on the unit circle, that's like yesterday where we use our calculator, radian or degree mode. We have no other option. If we had to memorize every single set of right triangles, like a 90, 70, 20 triangle and the ratios to the sides, then they wouldn't be special anymore. We only need 2. Plus, not all of them come out nicely right, but they all have some ratio. Okay, if you want to tape your little triangles into your notes, or if you want to toss them in the trash or recycle, that's totally fine with me. I'll come around and pick up the highlighters here in a little bit, but you do have a homework assignments on your gold sheet. And we're going to do quiz tomorrow, but the quiz is nothing with the unicircle, okay? So don't feel like you have to have the unicircle memorized tomorrow. It's just basic trig for 143.